Hi, we have a question in section 4.4, problem number 16. This is one of the application problems. Probably one of the harder ones in this section, probably one of the harder problems in this chapter, as a matter of fact. But it's problem number 16. It's talking about the a Norman window, which is basically what we call in the Midwest a wagon wheel window. And but it's got like a regular rectangular window with a half circle on top of it. And but what we've got going on here is we want to maximize the area of the window, but we only have a perimeter around the window of 20 feet total. So I kind of started some of the problems, and I also wrote a few formulas down to remind you what we need to use. But the circumference of a circle is 2 pi r, and the area of a circle is pi r squared. So we'll need these two formulas for the circumference and the area of that half wheel. And then there's the rectangular part of it. And so what I did was I have, like I said, I have 20 feet all the way around, from here all the way around 20 feet. So what I did was I made the radius of the wagon wheel x, which makes this 2x, which is the diameter of the half a circle. And so what I need to do is kind of figure out what all the lengths are in terms of 20 and x. And remember, I have 20 all the way around. So here is 2x. Okay, the circle itself is half a circle, so the circumference is 2 pi r. But since it's only half the circle, it's going to be just pi r. Now, pi r is the radius. Well, in this case, the radius is x. So the distance around the semicircle is pi x instead of 2 pi x. So it's pi x there, 2x down here. So I've used up 2x and pi x of my 20. Now remember, it's 20 all the way around. So this is just a part of the 20. So I take that from 20, and that's what's left over. But that is what's the leftover for the height of the window. But that's got to be divided proportionally between these two sides. So I divide this by 2. Okay? So what that becomes is going to be 20 minus 2x minus pi x. So it'll be 20 minus 2x minus pi x over 2. And that's a minus pi x because the minus has to go through. Okay, so that's the height of the window. So the reason I kind of got all the parts of this is because I got to find the area. And the area of a rectangle is base times the height. Now, they're not numerical, but they are. I have an expression for them. The base is 2x, and the height is this. So to find the area of the rectangular part of the window is going to be base, which is 2x, times the height, which is this 20 minus 2x minus pi x over 2. Now, that's the area of the rectangular part of it. Now, the circle is really half a circle. And remember, the area of a circle is pi times the radius squared. That's if it's a full circle. This is only half of a circle. So this one's going to be pi x squared, because the radius is x in this case. But that's if it was a full circle. So I divide that by 2 because I only have a semicircle. And then I add that on. So this is the area of the whole window, including the top itself. And when you multiply this out, it's going to be a mess. And but the thing is, you got to get it in terms of a quadratic, because we're trying to find the minimums and maximums in this section, remember? And so that means we got to be dealing with a quadratic. So ultimately, I need to get this thing in the form of ax squared plus bx plus c, because in order to find the maximum, then I have to use this a negative b over 2a. So I've got to get this in that form. And believe it or not, with a little bit of work, it's not too bad. Now, first of all, I'll cancel these 2's out because I can. And so then I get x times 20, which is 20x. X times negative 2x is a negative 2x squared. X times a negative pi x is a negative pi x squared. Plus pi x squared over 2. All right? Now, if you look at this, I have a lot of x squared terms. So if I take out the x squared, and I know there's a 20x, I'll deal with that later. But if you take an x squared out, the last three terms, I have -2, negative pi, and plus pi over 2. And then don't forget the plus 20x. And I know this is really, really bad looking, but really I found what I needed. I've got my a. My a is the number in front of the x squared. So that whole thing there is a, although it can be simplified a tad, it's going to be -2 minus pi over 2 times x squared plus 20x. So what I did was I took negative pi and add pi over 2 to get a common denominator and all that stuff. So this portion right here is the a, and this portion right here is the b. There is no c term. There is no constant here. So in order to find the maximum, I got to figure out what value of x that makes that occur. So h is equals to negative b over 2a. So it's opposite of the 20, so it's negative 20 over 2 times a, and a is this big long expression. Well, that's not too that bad. It's just -2 minus pi over 2. Now, what I would probably do at this point is to distribute the 2. So this is equals to -20. Or what you could also do is divide these by 2, but that ends up with still the fraction. So I think I'm going to go ahead and distribute the 2. Although I could cancel these out and make that a -10 on top. But if I do that, then I'm going to have a fraction here. So I think I'm going to leave it the way I got it and just distribute it. So 2 times -2 is -4. And then 2 times negative pi over 2 is negative pi. So it's -20 over -4 minus pi. Now that value of x, you'll have to plug it into our calculator to figure that out. And I will suggest that you need to put parentheses around that. So that would be the value of x, actually, that will produce the maximum. So once you've got that, okay, then what you would do is you could double it, because it's 2x is the actual base of the window. So once you figure out what this is, you need to double it, and that'll give you this dimensions. And don't be surprised that it is a decimal. And then when you get that, plug the x in this as well, and that'll give you the height of the window. And that will give you the actual dimensions of the window that will produce the maximum number, the maximum light that will come into the window. So now I think it might ask you in this problem as well to figure out what the actual area is. So once you figure out what this is, and I'm not going to do that, I'm going to lay that up to you. Once you do that, then you take that number and you can actually plug in into one of these expressions on here, and that'll give you the area. Or you can go back to the old basic, figure out these numbers using your picture, multiply that out and find the area, the rectangular portion, and do the semicircle area, and then add those numbers up. It's kind of more of a manual thing. The more mechanical way of doing it is whatever that number is, plug it back into this number for x, and let's let the calculator do all the work for you. So. But anyway, like I said, this is probably one of the more difficult problems in this chapter. So if this is the only thing you don't understand, then you're okay. So, but anyway, this is problem number 16, section 4.4. Thanks.